Thank you very much for inviting us to introduce Project Origami. My name is Andres Garcia-Saavedra. I'm a principal research scientist at NEC Laboratories Europe, and I also the technical manager of this project. So let me start the introduction of Origami by introducing the partners on the consortium that actually makes or will make this project successful. As you can see from the screen, we have 12 partners distributed among different states, member states or associated members. We have two large operators, Telefónica in Spain, which happens also to be the project coordinator of the project, and Telecom Italia. And we have two vendors, NEC and IS Wireless. And we have four SMEs from Norway, UK, Spain, Greece, and we have four renowned research institutes and universities like TU Delft, University Carlos III in Madrid, or India Networks. So I think this screen, this illustration here represents pretty well the whole scope of the project, or the overall goal of the project, right? So in the left-hand side, what you can see is a set of barriers. So we have identified a concrete set of barriers from 5G systems. I will get into details of these barriers later on. And these barriers, or the description on the study of these barriers, have actually motivated us to propose innovations, architectural innovations on top of today's 5G to achieve a concrete set of goals, as you can see on the right-hand side, like achieving global standards for telco APIs, achieving green transition, affordability and accessibility, and fostering innovative business models. So in between, like I said, to map the barriers or the solutions to those barriers to achieve the high-level targets that I just mentioned below, in between we have we are proposing three key innovations, architectural innovations. Compute continuum layer, which basically, I will talk about this later on as well, but the idea is basically to abstract a continuum or a fabric of computing resources. I think some other projects have talked about this before, to provide a fabric of computing resources to address a whole set of different projects with latency and performance guarantees. The globally available service-based architecture here, the idea is to connect different planes together. By different planes, I refer to those coming from different standardization bodies like 3BP, ETSI, Open RAN, but also through other planes that have been defined in previous projects before, like one plane that we call network intelligence plane. For all that has to do with not only artificial intelligence and machine learning, but also more traditional optimization solutions based on convex optimization, statistical analysis, all those things. We want to integrate them into a single common plane, along with today's artificial intelligence solutions. And the third architectural innovation, we call it zero trust exposure layer. This is basically, an exposure layer that aims to foster new business models to improve competitiveness in this industry. This can be seen as a generalization of what we had before as network slicing, where we provide an exposure layer where different third parties can actually address the resources of mobile networks in a way that they do not require the mediation of the infrastructure owner, or in a way that we can actually build faster new business cases. So we have a set of technical objectives. The first one is evolving the architecture of core mobile systems. And here the idea is, like I mentioned before, the first objective towards meeting this new architecture is to create this globally available service-based architecture, which I talked about. Something that we will do to demonstrate the feasibility of this innovative solution is to actually build an experimental proof of concept that shows the advantages of this approach. The second sub-objective, in this more overarching architectural objective, is concerning this compute continuum layer that I mentioned before. And the idea is to, homogenize a heterogeneous the computing fabric made of hardware accelerators, general purpose processors, including novel computing models such as quantum computers, quantum communication, these sort of things. We would like to offer to build abstraction layers, and so different vendors and developers can actually build on top this heterogeneous computing fabric without really caring too much about what's underneath, but with performance guarantees, which are critical for many problems and operations in mobile networks, for example, base stations for signal processing and things like this. And the last one is what I mentioned before, zero trust exposure layer. Again, the idea is just to innovate or to foster new business models that we haven't seen before, right? By allowing more dynamicity and the ability to build virtual networks faster without really the mediation of third parties that may slow down the creation of mobile networks. And for each of these architectural innovations, our goal is actually to build a proof of concept that demonstrate the advantages of each of these innovations. So I mentioned before also that we want to connect different planes like 3GPP, Open RAN, ETSI, with a plane called Network Intelligence plane. So as an objective two, as a key objective, objective two, here what we want to build is, well, network intelligent solutions that exploit these architectural innovations to solve the set of barriers that we identified before, right? And here in this illustration, we kind of summarize the 8 barriers that we have identified in the project, and we will focus in the project to basically break them. So the first barrier has to do with unsustainability, specifically on the radio access network, and building, virtualized radio access networks that are more affordable and more sustainable than they are today, right? And here the idea is to exploit the compute continuum layer using network intelligence solutions on top of this new layer to, improve the sustainability of virtualized RAN solutions. And again, we will build a proof of concept to demonstrate this. Second barrier goes in the direction of interoperability of RAN components. All the fuss with Open RAN and the idea of bringing different vendors together, right, requires actually having the vendors being interoperable between each other, right, or different components of the network being able to be operable between each other, right. Of course, this involves standardization, but it also involves willingness and certain mediation tools that we plan to work on during the scope of the project to make sure that competing vendors can actually talk to each other in the same systems. So objective 2.3 basically has to do with building network intelligence solutions to break barrier 3, which has to do with, nowadays we more and more try to solve more and more complex problems, network problems, and all these optimization problems typically require a lot of computing resources. So here the idea is, okay, how we can solve all these complex network optimization problems fast, with very low latency, right? And this has to do with solving very large problems with new solutions. For example, quantum computing, how to exploit quantum computers to solve very large scale network optimization problems, but we are open actually to study also other solutions. The next one, barrier 4, is basically on underutilized modern programmable transport systems. So we believe that the transport networks today, backhaul, fronthaul, midhaul, and so on and so forth, are underutilized, and could be all these devices could actually be used for more tasks rather than just transporting data from one place to the other. They actually today smart switches have a computational power that could run some operations to alleviate the latency of things like face recognition or now the execution of LLMs, right? As data traverses or flies from the user equipment to a data center. So in between, we have actually devices, data passes by many devices that have computational capabilities. And the idea here is to exploit all these capabilities, to alleviate the computational burden at the end, and therefore provide services, high competence services with very low latency. Barrier 5 and 6 are very related. This is the idea of that we have identified a lack of global service APIs and also an obsolete trust model. And here, this is the idea of actually, having a dependence of a SIM card, which is attached to a single operator. And if you roam to another country, well, you have a whole set of signaling exchange to change to another operator. So there is an intrinsic lack of trust between vendors and operators, and also a need for having a global service API, so you can actually create the concept of a global operator, right? That doesn't really reduce the overhead when you have to roam between countries, and this is specifically relevant for IoT. And yeah. And the last tool, barrier 7, basically has to do with inadequate network data representation. We believe that data in networks can be represented better to building systems, for example, for anomaly detection. And barrier 8 is that we have identified that in today's systems, we have a huge amount of control plane signaling that we believe can be alleviated substantially for 6G. Just to conclude, I'm not going to get into details. So what I have presented are basically our technical objectives to build the view that we have in ORIGAMI. And of course, to wrap up all these technical objectives, we have a set of performance objectives. I'm not going to go into this in the interest of time, but just to let you know that we have very concrete set of KPIs with very concrete targets when building the solutions that address the barriers that I mentioned before. And in addition, we have committed to empirically demonstrate each of these solutions with empirical proof of concept. We have 8 barriers, so we have committed to prove the feasibility or the way how we break these barriers through 8 proof of concepts. Of course, we have also a set of productivity objectives in terms of IPR generation, contributions to open source projects, and scientific publications, where here we are we have very high targets that we plan to satisfy. So this is all from my side. Thank you very much for attending, and of course, you're welcome to visit our website for more information or contact me or the project coordinator.